Stoichiometry. Now we're looking at limiting reactants. And this practice, I'm expecting you to just do one problem, but we're also going to be looking at a simulator as well. On the back of this one page, I'll show you an example, so you can just follow along for this one, either in class or in this video. But I'm going to assume that you have already read the directions so I can work on the exemplar with you. Okay. Now we're looking at this limiting reactant simulator, and in the simulator there are 5 different chemical reactions to choose from, but I will be using the first one, so please don't use the first one in your individual practice. Now take a look at the right side. I can change the initial mass of one of the reactants, okay, so NaCl. And then on the bottom left, I can add more of the other reactants by clicking any of these 2 buttons here. So in my reaction, silver nitrate is reacting with sodium chloride, and it's going to produce silver chloride and sodium nitrate. The first thing that I want to do is write down this chemical equation on my sheet. So I'm going to go ahead and write it. We have silver nitrate. It is reacting with sodium chloride. It's going to produce silver chloride. Silver chloride and also sodium nitrate. And then notice that on the title it's actually unbalanced. So I'm going to have to add numbers in front of these to see if they're balanced. So actually, let me roll it at the very bottom. I'm going to move it to the top here. So I'm going to balance this chemical equation real quickly. Let's see on the left-hand side how many silvers, nitrogens, oxygens, sodiums, and chlorides do I have. On the right-hand side, I'm going to do the same thing. How many silvers, nitrogens, oxygens, sodiums, and chlorines do I have? I'm going to count them really quick now. Silver at 1, 1, 3, 1, 1. And on the product side, we're doing the same thing. I've got 1. For nitrogen, there's 1. Oxygen is 3. Sodium is 1. Chlorine is 1. Okay. In this instance, actually, all of the coefficients are going to be 1 because this unbalanced chemical equation is actually already balanced. So I don't have to do anything here. For yours, you might have to actually balance it, all right? Okay, but now I'm going to look back at the simulator here. I can change the amount of the sodium chloride, the initial amount, and as I'm clicking this button, you're going to notice that the bar graph on the bottom changes. The bar graph keeps track of how many of each chemical there is inside this beaker, okay? So let's say that there's 20 grams of sodium chloride at the beginning. I didn't add the silver nitrate yet, but as soon as I add it, you're going to notice that it creates product. So here we go. I'm going to add 1 gram at a time, and every time I'm adding more and more, the amount of product just increases. You're also going to notice the amount of sodium chloride is going to decrease. It's because the sodium chloride is reacting with the silver nitrate. And then eventually, if I do this enough, it'll reach a point where, okay, all of the sodium chloride has reacted. And now the silver nitrate has nothing to react with, all right? If I stop right here, what I can say is, in my beaker, there is no more sodium chloride. That is the limiting reactant. And also, in my beaker, there's extra of silver nitrate. That's the excess reactant, all right? But for this problem, I'm going to start new. I'm going to choose an arbitrary amount. Let's say I have 40 grams of sodium chloride here, and I'm going to add exactly 40 grams of silver nitrate as well. Let's see what happens. So add 10, 10, 10, 10, and then you're going to notice there's 40 grams of silver nitrate added, all right? And then right here, this is what's going to be a result of these 40 grams of sodium chloride and silver nitrate added. Okay, but let's record all this information down onto our sheet of paper. Now, in the box that says initial reactant amounts, that's what we actually added into our beaker. I specifically chose 40 grams of sodium chloride and also 40 grams of silver nitrate. Okay, that's what I added into this beaker. What's the outcome of this reaction? Well, the outcome of reaction amounts, the graph shows it to you, so you're just going to have to write down what the graph says. For the reactants, there is no more silver nitrate, so 0.0 grams. There's still some silver chloride left, 26.2 grams of sodium chloride. And then for the products, we have some products here. We have 33.7 grams of silver chloride and also 20.0 grams of sodium nitrate. Okay, so that's the outcome of the reaction. You're going to notice that one of the reactants is completely gone. It has been used up. And the other reactant, there's extra, it is an excess reactant. Okay, on the bottom here though, we are actually going to do our own calculation to check to see if the simulator is right. It's supposed to be right, but let's check to see if it's right, and check to see if we really understand this. Now, basically, we shouldn't need a simulator to figure out whether which reactant is a limiting reactant. But this simulator is saying that the silver nitrate is a limiting reactant. And I'm going to show you that you can actually prove this with your calculations, okay? And what this means is it entails two calculations since we have two reactants. For the first calculation, we're going to start with our 40 grams of sodium chloride. All right, this is my first conversion. We're starting with 40 grams of NaCl. Okay, and I know that my second reaction, I'm starting with my second reactant. In my second calculation, I'm starting with my second reactant. My second reactant is 40 grams of silver nitrate. Okay, that's what I wrote over here. And for both of these reactions, we know that we're trying to figure out one of the products. So I'm just going to arbitrarily pick one. I'm just going to pick silver chloride. How much silver chloride is supposed to be produced? We can actually check this. So for both of these calculations, we're doing a gram-to-gram calculation to silver chloride. Every gram-to-gram calculation requires 3 conversion factors, so there we go. For the first one, we're going to convert our grams of our first substance to moles of our first substance. All right, and this thing is a molar mass. Okay, for the molar mass, we are supposed to look at the periodic table to find sodium and chlorine to get the molar mass. So I'm going to do that real quick on my calculator. Sodium happens to be 22.99, and chlorine happens to be 35.45. Molar mass of sodium chloride is this right here, 58.44 grams per mole. All right, the unit cancels out as grams of NaCl, grams of NaCl. For the second conversion factor, we're trying to go from moles of our first substance to moles of our second substance. So moles of our first substance is moles of NaCl. Moles of our second substance, I'm going to pick to be the first product. So moles of silver chloride. All right. This conversion factor is called a mole ratio. For a mole ratio, you're supposed to look at the balanced chemical equation. And earlier, when I tried to balance it, I learned that it's actually already balanced. So according to my balanced chemical equation, there's 1 mole of silver chloride, and there's 1 mole of sodium chloride. Okay, the unit that cancels out is moles of NaCl and moles of NaCl. For the third conversion factor, we're trying to go from moles of our second substance to grams of our second substance. So we're going from moles of our second substance to grams of our second substance. All right, and this third conversion factor is a molar mass. For a molar mass, we look at the periodic table to get the numbers. So we look for silver and chlorine. Silver happens to be 107.87, and chlorine is 35.45. You add those two together, and you should get 143.32. Okay, so the molar mass of silver chloride is again 143.32 grams per mole. All right, the unit that cancels out is moles of silver chloride and moles of silver chloride. Now we have grams of silver chloride, one of the amounts of our products. All right, let's calculate this out real quickly. So we're going to start with, let's see, 40 divided by 58.44 and multiplied by 143.32. What I'm getting is 98.09 grams. 98.09 grams. And then this is for silver chloride. All right, we're going to do this conversion again, except now we're going to start with our second reactant. Our second reactant is silver nitrate, and I happen to pick 40 grams of it. So we're still doing a gram to gram conversion, and I'm trying to figure out how many grams of silver chloride is being produced. So since it's a gram to gram conversion, that means we need to do 3 conversion factors. All right. And for the first conversion factor, it's literally going to be the same process. We're going from grams of our first substance, which is silver nitrate, to moles of our first substance, which is moles of silver nitrate. This is a molar mass. For a molar mass, you look at the periodic table. So we have silver, nitrogen, and oxygen. Silver is 107.87. Nitrogen is 14.01. And oxygen is 16, but there's 3 of them, so make sure you multiply by 16. Or multiply it by 3, my mistake. And what I'm getting is the molar mass is 169.88 grams per mole. 169.88 grams per mole. Okay, unit that cancels out is grams and grams of silver nitrate. Now in our second conversion factor, we're trying to convert from moles of our first substance to moles of our second substance. So moles of silver nitrate to moles of, and I decided silver chloride, all right? Now this thing is a mole ratio. For a mole ratio, you look at the balanced chemical equation. And again, in my balanced chemical equation, they all happen to be a 1-to-1 ratio. So how many moles of silver chloride? Just 1. And how many moles of silver nitrate? 1 again. The unit that cancels out here is moles of silver nitrate and moles of silver nitrate. All right. Now for our very last conversion factor, the third one, we're trying to go from moles of our second substance to grams of our second substance. Okay, so moles of our second substance is moles of silver chloride. Grams of our second substance is grams of silver chloride. And this third conversion factor is a molar mass. For a molar mass, you look at the periodic table to get the numbers, but I happen to already have done the molar mass of silver chloride. So I'm just going to write that same number down here. The molar mass of silver chloride is 143.32 grams per mole. The unit that cancels out now is moles of silver chloride and moles of silver chloride. And now we are left with grams of silver chloride. Again, okay, we'll go ahead and write down the answer to this, but we're going to type in our calculator. 40 divided by 169.88 times 143.32. Okay, what I'm getting here is 33.75. 33.75 grams of silver chloride. Okay, now we did two calculations, and I'm going to tell you the one that is the theoretical yield, the amount of silver chloride that's supposed to be produced, is the one that is the smaller number. So that means it was supposed to be the second one. You're supposed to produce 33.75 grams of silver chloride. And what that means here is, since this is the amount that's actually produced, that means this reactant, the 40 grams of silver nitrate, this reactant is the limiting reactant. This ran out first, all right? So let me go ahead and label this before I explain. So this is the limiting reactant, the silver nitrate, because it runs out first. And this right here is the theoretical yield. Since the silver nitrate ran out, you can only produce 33.75 grams of silver chloride. And if you check our simulator here, or actually I already wrote it down. You don't even have to check the simulator. If you check our outcome of the reaction, the numbers that we got from the simulator, let's see, which one's the limiting reactant? It is indeed silver nitrate. Look, there is no more silver nitrate at the end of the reaction. And then if you look at the theoretical yield of the product that you chose, I chose silver chloride. Look at this. 33.7 grams of silver chloride should be produced, which is the same amount that we calculated right here. All right, so if you really wanted to check how much silver nitrate is going to be produced, you can just do two calculations again, but you do know that the limiting reactant is silver nitrate. So if you start with 40 grams of silver nitrate and you convert to grams of sodium nitrate, it should be about 20 grams left. But I just wanted to give the simulator to you just so that you can kind of tweak the numbers and see for yourself what it really means to be a limiting reactant and an excess reactant, and for you to actually check with your own calculations that it is correct. All right? Okay, so make sure you do one problem of your own from the simulator. Again, I want you to check either the second, third, fourth, or fifth equations. Do not do the first one because I've already done the first one. And then just pick arbitrary amounts for your reactants. Record down the results of the experiment, the outcome amounts, and then check to see if they are correct. Check to see if you got the limiting reactant and one of the products correct with your own calculations. All right? All right. Yeah, have a good time.